This is Maldonado here, teaching you 5.5 add and subtract rational expressions. All right, so in the previous section, what we did was we multiplied fractions and we divided fractions and simplified fractions. So now adding and subtraction is something a little different, right? So let's just think back when we were working on them. If I told you to take 2/7 and add 3/7, what would you do? So the idea here is since the denominators are the same, you can just add the numerator, keep the denominator the same, okay? And there you go, there's your answer. Now, not always are you gonna have a common denominator, so let's say I had told you to add 1/4 plus 1/3. Okay, what are you supposed to do to kind of convert these fractions to have the same denominator? Well, what you wanna do is you wanna say, okay, I need to multiply this side by 2. Now, if I do that to my denominator, I need to also do that to the numerator. And I'm going to multiply this one by 3 so that they both turn the denominator into 6, right? So I get 3/6 plus 2/6, and that's going to give me 5/6. Okay. Now, one last one. We'll do one that's a little more complex because remember, we're always looking for the least common denominator. We're not just going to be multiply denominator times the other denominator. So let's say I had 1 over, say I had 1 over 24 plus 2 over 6. So what's the common denominator here? The common denominator is actually 24, right? This 24 is kind of like the same thing as 6 times 4 in factored form. So what do I need to multiply this fraction by? I need to multiply this fraction by 4 over 4 so I can get the 24. So that gives you 1 over 24 over plus, 8 over 24, which is going to give me 9 over 24. And then we know that that's going to simplify by 3, so we get 3 over 8. Okay, so again, all of these topics you've learned in the years past. It's just a matter of doing this with polynomials now, and that's what I'm going to try to show you on these next slides. Okay. All right, here, perform the indicated operation and simplify. So here, they're telling us to subtract the two fractions. So we can. The reason why we can is because notice that their denominators are the same. All right, so 7 minus 5 is 2 over, the denominator is going to say 12x. Now, from the previous section, can we simplify this? The answer is yes. We get 1 over 6x as our final answer. 2 and 12 simplify 1 over 6. All right, so when it's common denominators, it's nice and easy and straightforward. Just follow the same rules you learned back in 5th grade. All right, here we go. We get 2 plus 1 over 3x squared. 2 over 3x squared plus 1 over 3x squared. So that's going to give me 3 over 3x squared. All right, and what simplifies here? Well, the 3's do, so we get 1 over x squared as our final answer. All right, again, common denominators make our life easy. Let's look at the next one here. We have 4x over x minus 2 minus x over x minus 2. Sorry, I keep reading the numerators only. So the denominator is the same, so we're going to keep that. Okay, now what is 4x minus x? Yeah, that's right, that's 3x. Now again, remember from the previous section, we cannot simplify these, right? Because the x is married to the 2, so we can't just simplify. So there you go, there's your final answer. It's just a quick subtraction problem. Okay, common denominators are our friend. All right, let's look here. We have 2x squared plus 2 over, 2x squared over x plus 1 plus 2 over x squared plus 1. Notice that the denominators are the same. Denominators are the same. We get x squared plus 1 here. In the numerator, I get 2x squared plus 2. Now, for this one, it's the first one they're introducing to you like this because it's very important for us to know. After we add, we need to see if anything factors. In all the previous examples, nothing did because they were all quite simple. But here we can actually factor the numerator into 2 times x squared plus 1 over x squared plus 1. Then we know from the previous section that the x squared plus 1s are going to cancel out. So the only thing I have left is 2. So my final answer is 2. Okay, so once you add them, it's very important that you guys go ahead and try to simplify the fraction if possible, right? It's not always possible, but in most cases you might have to do that. All right, adding or subtracting with unlike denominators, right? So now we're going to look at this. Again, we covered how to get the common denominator if there isn't one with numbers, but now let's look at a case if we have to do it in terms of expressions. Okay, here we go. 3 over 4x minus 1 over 7. Okay, so what I want you guys to kind of get used to here is like, okay, if I look and I compare my two denominators, right? I'm going to strictly look here, okay? Do they share anything in common at the moment? 4 doesn't share anything with 7. 7 doesn't share anything with 4. So it doesn't look like they share anything in common. So what we're actually going to do is we're going to multiply this right-hand side by 4x over 4x. Notice that 7 times 4x will give me 28x. And then I'm going to multiply the left-hand side here by 7. Okay, and then that's going to give me my common denominators. Now, when you're adding or subtracting, first convert your numerators, and then you can go ahead and add or subtract. So what I mean by that is multiply it out first. So we get 21 over 28x minus 4x over 28x. Now we converted these fractions to have the same exact denominator. So I get 21 minus 4x over 28x. Nothing here is going to simplify. There is no GCF in the numerator. So there you go. There's the first one where you had to find a common denominator. All right. Let's look at the next one. Okay, here. This is definitely a good one for you guys to see because it's a little more complex. We have to think a little bit more, right? So here I have 1 over 3x squared plus x over 9x squared minus 12x. So what you need to do first is factor your denominator, right? So what I'm going to do here is, just to save some space for us, is I'm going to rewrite this denominator in factored form. So that the GCF between 9x squared and 12x is 3x times x minus 4. Okay, so now what I want you guys to do when you're thinking about this is ask yourself, okay, if I look at my first denominator here, what does my first denominator have that the second denominator does not? Now it has the 3, it has ax, but it doesn't have the second x. So we're going to have to multiply the top and bottom here by x. Now if we look at the right-hand side, what does the right-hand side have? What does this one have that the left-hand side is missing? It has the 3, it has the x, but it does not have the x minus 4. So what we're going to do here is we're going to multiply the left-hand side by x minus 4. All right, so now let's do some algebra here. So we're going to have x minus 4 in the numerator. In my denominator, it's usually easier if you just leave it in factored form. You only have to multiply the numerator portion of the fraction. So we're going to have x times x, which is x squared. Right, these two multiply together give you x squared, and then the denominator we're going to get 3x squared times x minus 4. Okay, so now what we're going to do is we're going to add the numerator. So that's going to give me x squared plus x minus 4 over 3x squared times x minus 4. Now this numerator here does not factor, okay, so then it looks like this is going to be our final answer, right? X squared plus x minus 4 over 3x squared times x minus 4. All right, so again, just identifying what is missing in denominators is going to be very important when we start working, with these problems. Compare the denominators. Ask yourself what is missing on each of these denominators. Again, we have plenty to do, so we'll just do these examples as they come up. All right, so here, again, you can factor this, you can factor this. Let's do that first. So we get x minus 4, x plus 3. In this denominator, I get 12 times x minus 4. Now, we are going to be comparing this denominator and this denominator. Okay, so what does the left-hand denominator have that the right-hand denominator does not? So the left hand has an x minus 4, but there's an x minus 4 here. Here, there's an x plus 3. There isn't an x plus 3 here, so we need to multiply this side by x plus 3. All right, and there's nothing else to compare from the left to the right. Now let's look from the right to the left. The right-hand side has a 12. Does the left-hand side have a 12? It does not, so we need to multiply by 12 over 12. X minus 4, we just added this x plus 3, so there's an x plus 3 on the other side. Okay, so now we multiply the numerators. We get 12x over. We're going to keep this factored. I like the denominators factored. Leave those untouched. plus the numerator is going to be 5x plus 15. You must multiply the numerator, okay? The numerator must get multiplied, and we are going to be distributing that 5 into those two terms. The denominator, we keep it factored. We like it factored. All right, then we add, so that's going to give me 17x plus 15 over 12 times x minus 4 times x plus 3. Okay, and then there you go. There's your answer. All right, so again, factor your denominators first. Compare both denominators to see what's missing, what can you use, what can we multiply by. You must multiply the numerators and then just go ahead and finish the operation, whether it's addition or subtraction. Okay, next one here. Oh, did I do the same one twice? I did do the same one twice. All right, so we don't need to do this one, sorry. Okay, here, perform the operation and simplify. Okay, so again, factor your denominators. We need to make sure we factor. So that's going to be x plus 2 minus 6. Here we have x plus 2, x minus 2. Now this one here for sure is going to take a little bit more work than what we're used to. All right, so here we're going to definitely multiply. Look here, x plus 2, there's an x plus 2. You have a second x plus 2, so we actually have to multiply this side by x plus 2 because this side does not have two x plus 2s. And we're going to have to multiply the left-hand side by x minus 2 because there's an x minus 2 here and there wasn't one on the left-hand side. Okay, so now we're going to have to do quite a bit of multiplication in the first numerator. So x plus 1 times x minus 2, we're going to have to FOIL that. We get x squared minus 2x plus x minus 2 over, we're going to keep this factored out. I'm just going to write it as squared because there's two of them. Minus 6x plus 12 over x plus 2 squared x minus 2. Okay, so now we need to combine like terms in the numerator. Okay, so we're going to subtract. Now, again, with subtraction, it's always tricky. Make sure we change the sign of these two terms when we're subtracting, right? So x squared does not combine with anything, so I'm going to have x squared. Then I have negative 2x plus x is negative x minus a 6x. So that's going to give me negative 7x. Then I have a negative, I have a negative 2 and a negative 12 because I have to distribute that. That's going to give me negative 14 over x plus 2 to the second and x minus 2. Now the numerator does not factor, so that's going to be my final answer. We have x squared minus 7x minus 14. My denominator is going to stay in that factored form. Now anytime a factor repeats, we know just raise it to whatever power, how many times it repeats. So in the denominator, x plus 2 occurred twice, so we just raise that to the second power to deal with that. Okay, a complex fraction. Okay, so now, pause the video here, kind of read this a little bit, understand that there's two different forms of doing this. Now, the method that works the best for us here is actually going to be a little bit of method 2 here, except that I am going to be figuring out here how we can do this a little bit easier. Okay, so take a look at it and we'll go ahead and try an example. Okay, so here we have a complex fraction, right? Now, when you're working with something like this, when early on when you're working on this, you probably would have subtracted these two first, found the sum of these two, and then divided those two fractions once you got that answer. Now, that's perfectly fine. The only thing is that's going to take quite a bit of time for you guys to do that. So instead, what you should do is, let's look at these as fractions. So in a sense, we have just multiple fractions in the problem. Okay, now if I asked you to find the common denominator for all four fractions, what would the common denominator be? For all four fractions. So we have to pay attention and look closely at x1, x1. What would be the common denominator for all four of them? Okay, now if you guessed x, you're right. Okay, x is the common denominator. So what I'm going to do is I'm going to take this common denominator and I'm going to multiply x times every single term I have here. Okay, and now look at the beauty of doing this. So x and x are going to cancel, x and x are going to cancel here. Do I have any fractions now? I have 2 minus 4x over 2 plus 3x, and that's your answer. All right, so notice what happened here was the x is canceled, 2 is by itself, so that's where we get the 2. X times 4 gives me 4x. The x is canceled here. 2 is by itself, so there's the 2. And then x times 3 gives me 3x. No complex fraction, it's just a simple fraction now. Okay, so multiplying by the common denominator is what we're going to be wanting to do, all right, when we work with these. All right, awesome. Let's look at the next example. All right, so this one obviously is much more to the level of what we're going to be doing. We have to find the common denominator. So the least common denominator, the LCD. Okay, so what you need to ask yourself when you're comparing is look at all the denominators, okay? What would be my common denominator for all of them? So just ask yourself what's missing, right? So if I look at this one here with the x plus 5, x plus 5 is here, x plus 5 is here, but this one's missing an x plus 5. So we're definitely going to have an x plus 5 in the problem. Now this one has an x minus 3, but the other two don't, so we're also going to need the x minus 3. We're going to need both parts of it, okay? So we need to make sure that they all have it in common. So that's my LCD. I'm going to take this LCD and multiply all the parts of the fraction. So the LCD in the numerator, we have x plus 5, x minus 3, times 2 over x minus 3, x plus 5, x minus 3, over 1 over x plus 5. Excuse me. All right, so now we simplify. Canceled. 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 So what do I have here to work with? I have 3 times x minus 3, so that's 3x minus 9, over, I have 2 times x minus 5, so that's 2x plus 10. Right, these two multiply together give me 2x plus 10. Then I multiply these two together here, so that's x minus 3. So that's going to give me 3x minus 9, over, if I find the sum of the denominator, I get 3x plus 7. There you go. There's your answer. All right, so hopefully this video helps. Okay, I understand that this section is going to be a little bit more difficult. Again, if you have questions, feel free to reach out to me. I have no problem answering them for you. Okay, just get me those as soon as you can if you have them. Keep in mind that I understand that this section is much more difficult than the previous one, but hopefully this video helps out. Again, pause the video whenever you need to. Okay, rewatch the video if you need to rewatch it. Because I'm pretty much, this is how I would do it in class. It's just, I'm not there giving you my physical antics when I'm actually teaching you. But this is pretty much, what we're doing. All right. So again, please reach out if you have any questions, and I hope this video helps you guys. All right. Have a good one.